Welcome back, grade 12s. So we are continuing with our videos on revision on assets and bases. So this is part 2 of our video. So I'm gonna do this question. Now this question is a second part of the entire question on question 10. So the first part is theory. Define the acid according to Laurie Bronsted. Calculate the concentration of OH if the pH is that. So all of those calculations you can do on your own and identify the conjugate of a base, and also write the ampholytes, definitions, and all of those things you can do on your own. So I'm not gonna look at the first part of the question. I'm just gonna zoom into the calculation part, the stoichiometry part of the question. All of the theory part, I'm gonna leave it for you. So question 10.3 is saying now a laboratory technician wants to determine the concentration of the hydrochloric acid sample. He adds 5 cm cubed of the HCl sample to 495 cm cubed of the distilled water to give 500 cm cubed of a dilute hydrochloric acid. Now, during a reaction, 50 cm cubed of this dilute hydrochloric acid solution reacts completely with a 0.29 gram of a sodium carbonate Na2CO3. This is the picture that they gave us. They said now the balance equation for the reaction is this one, and they said calculate the concentration of the hydrochloric acid sample for 7 marks. So I want us to look at the question again, or the statement again, and then let us draw our own picture to understand what we are given. A lab technician wants to determine the concentration of HCl sample. He adds 5 cm cubed of the HCl sample to a 495 cm cubed of distilled water to give 500 cm cubed of a dilute hydrochloric acid. So my picture looks something like this, similar to the one that we did previously. I want your imagination now not to be confused. So you have a sample of HCl. The volume of this HCl is 5 cm cubed. This HCl is added to water, but I'm going to add water to it just to give a same picture as the previous question. So 495 cm cubed of water is added to this HCl. Now 495 plus 5 is going to give you 500 cm cubed. So we have a dilute now, HCl. It was concentrated before, it was 5 cm cubed, it was mixed with water, it became dilute, and there's a volume of 500 cm cubed. That is what happened initially. Then what did they do with this dilute 500 cm cubed? Now they said during a reaction 50 cm cubed of this dilute hydrochloric acid reacts completely with a 0.29 gram of a sodium carbonate. So they took 50 from this 500 cm cubed, they took 50 cm cubed of the same dilute HCl. Now the volume of that they took is 50, and they reacted with a solid sodium carbonate, solid form, like it can be a tablet or whatever. So they took now this sodium carbonate and they added to this volumetric flask, which is filled with HCl. The mass of that sodium carbonate is 0.29 gram. Then there's a product that is being formed. Now what's important here is this balanced equation. The balanced equation is Na2CO3 plus 2 HCl. Look at the ratio. 1 of sodium carbon dioxide sodium carbonate reacts with 2 of HCl. So I want you to note now, this is the ratio between the HCl and the sodium carbonate. And then there's this final solution now, which is 2 NaCl, I think, plus CO2 plus H2O. Okay, now this is what they gave us, and they said now let us calculate the concentration of the hydrochloric acid sample. So we want now the concentration of the sample. We want this concentration, the concentration of the concentrated HCl, or the concentration of the HCl sample. So this is the information that they gave us. I just want to give you the picture. There is nothing on the final that they said. We're not given anything on the final. It's just this part and this part. So let us start here. How can we find this concentration of this concentrated HCl? Okay, let's now determine the relationship between the concentrated and the dilute. Now, the relationship here, if you can see, let's say the number of moles of this concentrated HCl is equal to the number of moles of this dilute HCl. Now we can say here the number of moles is concentration times volume for the concentrated equals to the concentration times volume for the dilute. So we have the concentrations times volume for the concentrated and the concentration times volume for the dilute. And now we are required to find this concentration, and the volume now for the concentrated is this 5 cm cubed. So I'm gonna say it's 0.005 dm cubed. Now we don't know the concentration of the dilute, but we do know the volume, but we can find that concentration. Let's say the volume is 500 cm cubed divided by 1000, it's gonna be 0.5. So this is the method here. If we can find this concentration of the dilute, we can be able to find the concentration of the concentrated. So we're just going to divide by this 0.005. Then that's the concentration of the concentrated HCl. Now we need to find now this concentration of the dilute. So how can we find the concentration of the dilute? We need to find now the number of moles divided by the volume. So to find the concentration of this dilute, we need the number of moles, this number of moles. Now this number of moles of the dilute depends here. If we can find the number of moles here, then we can know the number of moles there. So this number of moles here for the dilute, we will need to know the number of moles of this sodium carbonate. So let's first go and find the number of moles of this sodium carbonate tablet, and then this number of moles we're going to equate it now to the HCl. You can see the number of moles of HCl is 2 times the number of moles of the sodium carbonate. So let's first find the number of moles of this sodium carbonate. Then we're going to multiply it by 2 to get the number of moles of the HCl dilute. So this is 0.29 grams. That is the mass of the sodium carbonate. Then we have to divide it with the molar mass of this. The molar mass, we need to check the periodic table. Okay, you can see now the sodium is 23. So we have 23 times 2 plus the carbon is 12 plus the oxygen is 16, and there are 3. So we need to find this molar mass. So is 23 times 2. Okay, is 23 times 2 plus 12 plus 16 times 3. So the molar mass, okay, I made a mistake here, is 23 times 2 plus 12 plus plus 16 times 3. So the molar mass now is 106. So we have 106 grams per mole. So that is the molar mass now for the sodium carbonate. So we divide here by 106. So we have 0.29 divide by 106. So the number of moles of the sodium carbonate is 2,7358. Let's say is 2,7358. Okay, it's fine. Times 10 to the power negative 3 moles. Okay, so now that we do know the number of moles of the sodium carbonate, we need to multiply now by 2 to get the number of moles for the dilute acid. So I'm just going to multiply this by 2, multiply it by 2, then I'm gonna get something like 5,472. 5,472 times 10 to the power negative 3. 5,472 times 10 to the power negative 3 moles. So this is the number of moles now for the dilute HCl. Remember, this HCl is 50 cm cubed. This HCl is 500 cm cubed. So the HCl on the left is bigger than the HCl on the right. Now, if you can check the ratio between them, if you set 500 divide by 50, that means that you get 10. So that means that the HCl that is on the right, this one, is 10 times bigger than this one. So it's 10 times bigger, the one that is on the left to the one that is on the right. So if we have this number of moles here on the HCl, which is 50, we can multiply this by 10 to know the number of moles of the dilute HCl on the left, because this one is 10 times this one. So let's just multiply this number by 10, then we know the number of moles in this 500 cm cubed container. So we're gonna say now this 5,472 times 10 to the power negative 3, let's multiply that by 10 to know the number of moles in the 500 cm cubed. So we have 0,005472. This now is the number of mole in the 500 cm cubed container. It's 0,05472. So the number of moles here is 0,05472. Let me check again. 0,05472. Yeah, 0,05472. This is the number of moles in this 500 cm cubed container. Now let me get the concentration now of this 500 cm cubed container. Let me do it somewhere here. So the concentration now of that is N over V. So the N is 0,05472 divide by the container is the HCl there is 500 cm cubed, that dilute one, so it's like 0,5 dm cubed. So this concentration now is, okay, so we divide 0,05472 by 0,5. This is in dm cubed now. So we get the concentration now, which is 0,10944 mole per dm cubed. Now this concentration is a concentration now of this dilute 500 cm cubed HCl. So it was this concentration here. So this is 0,10944. So it was this concentration. Remember, we said to find the concentration of this concentrated one, we said the number of moles of the concentrated is equal to the number of moles of the dilute. So it's C times V concentrated is equal to C times V dilute. So we do know the concentration of the dilute now. We do know the volume of a dilute. We need the concentration of the concentrated. The volume of the concentrated is this 5 cm cubed divided by 1000. It's going to give you 0,005. So the concentration now of the concentrated is this divided by this. So let's check on the calculator. It's 0,10944 multiplied by 0,5 and divide everything by 0,05. 0,005. So let's find this concentration. Okay, so the concentration now for the concentrated is 10,944 according to the calculator. Yeah, 10,944 mole per dm cubed. This is the concentration now of the concentrated HCl. I think my computer is freezing now. Okay, yeah, so this is how we do the calculation to find the concentration of the concentrated. It's similar to the previous example. So let's now, I will see you now on the next video.